Okay, so today we'll be talking about data visualization. So we'll be starting with data visualization today. Let me write. We have data visualization. So in data visualization, before we could just mention anything on data visualizations, there are some things that we need to know.
Okay.
Number one thing is when we are dealing with data, we have different types of data in particular. And the type of data we have will determine the type of visualization we use. Are you with me? So
Okay.
mainly we have four types of data. We have four types of data, which we have nominal, or let me say we have four level of measurements. Let me just call it level of measurements. We have four level of measurements. We have the nominal, we have the ordinal, we have the ratio, and then we have the interval. Now, when we're talking about
Please
nominal,
come again. The nominal.
we have nominal, we have ordinal, we have ratio, and we have interval.
Okay, sir.
So those are the levels of data that we have, level of measurement that we have. Now, what's nominal data? When we're talking about nominal data are categorical data. Are you with me? That does not have any hierarchical level, or which means there is no any superiority between those categorical levels. Now, for example, gender. Gender is a nominal variable because in gender, we'll be looking at either male or female. So we can't say that, okay, while collecting data, then you say male is more superior than female. So in that case, we can say that example of a nominal data is what? Is gender. Hope you get it right. Now, when we are now dealing with ordinal data are data that are in levels that have hierarchy. For example, levels in university, 100 level, 200 level, 300 level, 400 level. We know that 200 level is higher than 100 level.
Okay, sir.
We know that 300 level is higher than 200 level. We also know that the level is higher than 300 level. Now, note that this ordinal data is also a categorical data. Are you with me? Nominal data is a categorical data. Ordinal data as well is a what? Is a categorical data, or we call it qualitative data.
Okay.
So these two, both ordinal and nominal, we classify them as a qualitative data, or we can still call them categorical data. Now the third one, we have ratio. And we have interval. So ratio and interval, they are quantitative data. They are not qualitative, they are quantitative. So if I'm to talk about the types of data, some statistician will tell you that, okay, we have qualitative data or we have quantitative data. So qualitative data is also known as categorical data. So qualitative data is either ordinal data or what? Nominal. Is that ordinal variable or what? Nominal variables. While quantitative data, which we can also call numeric data, there are two, which are interval and what? And ratio. When we are talking about interval, example of interval is temperature. And if we look at temperature, for example, we have temperature 0 degrees Celsius, 5 degrees Celsius, 10 degrees Celsius. It is a numeric variable. And it can also classify it as interval data. Another example of interval data as well is year 2010, 2011, 2012, 2013, 2014, and the likes. It's also what you can also classify that as interval data. Now, when we're not talking about ratio data, ratio variables, example, we have weight, we have height, we have a lot of them. Now, how do we know if our data is interval and if our data is ratio? I will say it in a brief word that the difference between these two, though they are both numeric, but what you can use to differentiate between them is that if you look at ratio data has a known zero data, or let me say it has a particular range at which it is impossible. Now let's say for example height. We know that when you are measuring height, despite the fact that we have different measurement for height, you can measure in different scale depending on what you want to deal with. We also know that there are some scale in height that is impossible. For example, you hear that the height of something is minus so. Is it feasible? No, it's not. So it has a point at which it is impossible, at which it doesn't exist. So such numeric variable is also known as what? Is also known as ratio. Such data is known as what? Ratio data. The moment we're not dealing with something like, look at weight, for example. Weight. If the weight of something, if something weighs 50 kg, 60 kg, 70 kg, 80 kg, weight is also a ratio data. It's a ratio variable. Now, if something weighs 0 kg, what does it mean? It means the thing does not exist. Do you agree with me? So it means that the thing does not exist, because or something weighs minus 3 kg, something weighs minus 4 kg, something weighs, so immediately it gets to negative, it doesn't make sense anymore. It's not something that seems feasible again. So that is ratio. But when we're talking about interval does not have a known, or let me say a known zero values.
Someone, can you hear me, please?
Yeah, I can hear you.
Yeah, Faru just called me now. He said this was a past problem that I should send it on Telegram. So that's what I'm trying to do. So the last thing I heard was we were on ratio. He said it has.
Mo ń gbọ́ yín báyìí ò ṣe gbọ́.
So I said we have 4 levels of measurements. We have the nominal, we have ordinal, we have ratio, and interval. I said nominal data are the data where there is no hierarchy in between or among those variables or among those data. For example, gender. For gender, we have male, we have female. So there is not any hierarchical level for you to say that okay, male is superior to female. They are both nominal. Such data is what is nominal. Now the second one we have ordinal data. Ordinal data is where you have where they have hierarchy. And I said the example is our levels in school. University, for example, 100 level, 200 level, 300 level, 400 level. Now you can agree with me that 200 level is higher than 100 level, 300 is higher than 200 level, and the likes. Now this type of data is called ordinal data. Now both nominal data and ordinal data are both categorical data. They are both categorical, and we call them qualitative data. Another example of ordinal data is, example, we have bad, good, very good, excellent. It is ordinal. because you can agree with me that if something is good, it's better than being bad. Something is very good. It's trying to show us that it is more better than what than good. So like that. So both nominal and ordinal data are both qualitative data, and as well we call them categorical data. The third type of data that we have, the third level of measurement that I mentioned is ratio. And I said ratio data, they are what? They are numeric data. You understand? They are numeric. You see them in numbers. An example of ratio, we have weight, we have weight, we have height, and the likes. Also, we have interval data. Interval data is also a numeric data. Example, we have temperature, we have year, etc. Now, you see both interval and ratio, they are both quantitative data. We call them numeric data. Now, there's difference. How do we differentiate between interval and ratio? For ratio data has at a specific point, it has a value where it doesn't exist. Now, I said, for example, when you are dealing with weight, when we are dealing with weight, if someone weighs 0 kg, it means that such person does not weigh anything, and it's not even possible for someone to weigh negative value. So at that point, it doesn't exist. So you should agree with me that that kind of data is a what? Is a ratio data. Same thing applies to height. Imagine you collecting data for analysis and you see that the height of someone is minus something. It's not possible. It doesn't exist. So such data as well is a ratio data, though it is numeric, but we classify it as a what? As a ratio data. Another kind of data that we have is under interval. For interval, how do we know interval? Interval does not have a known zero value. That's it. And you would agree with me that example of an interval data is temperature. If a temperature is 0 degrees Celsius, then you cannot tell me that such person, the temperature is nothing. No, it's something. So that 0 degrees Celsius does not define the starting point of the temperature. And even if the temperature is negative value, yeah, it also exists. So such data that appears in such way, we call them what? We call them interval data. We call such data, we call them interval data. So if something is 5 degrees Celsius, let's say at a particular temperature, you find it to be 5 degrees Celsius, at that particular temperature, you find it to be 10 degrees Celsius, another temperature, you find it to be 15 degrees Celsius, then you cannot say that the distance or the difference between 10 degrees Celsius and 5 degrees Celsius is the same as the difference between 15 degrees Celsius and 10 degrees Celsius. No, if you are seeing it like that, definitely you are seeing it as if the starting value starts from 0. So that is how we differentiate between interval data and ratio data. We have a lot of quantitative data as well. We have age. Age is a quantitative data. We have income. We have travel distance to work. We have average speed and the likes. Another qualitative data, we have zip code. Yeah, we have zip code. We have marital status. Are you married? Now that marital status, you can tell me, will it be nominal or ordinal? Please, marital status, will it be nominal or ordinal?
Ordinal.
For you?
It will be nominal. Either you are single or you are married. So I think it's nominal.
I think it's nominal.
But it's not numeric.
Yeah, it's not numeric. We know that it is not quantitative, it is categorical.
Exactly.
I know under categorical, we have nominal. Are we to classify it under nominal variable or ordinal variable?
I say it is nominal because either it is marital, it's either you are single or married, so it is qualitative and nominal as well.
It is qualitative and what?
Nominal.
Okay. Okay. So what about grades? Grade, for example, you have A, you have B, you have now.
I thought you said nominal and number. They are numeric.
I said what?
Nominals are numeric.
Yeah, nominals are no. I said interval and ratio are numeric.
What about the nominals?
Nominal and ordinal are categorical.
Okay, I'm now going to differentiate between nominals and ordinal.
Now, ordinal has hierarchy. There is hierarchy for them, but for no hierarchy.
For nominal, rather.
Yeah, nominal, no hierarchy for nominal. But for ordinal, we have hierarchy.
I think it was not there when you were explaining. So when he was explaining, he said nominal, there is no hierarchy. Is either you are this or that in nominal measurement. But ordinal, there is like in form of level now, there's 500 level, 200 level, 300. So that's it. That's what I thought.
Okay.
Now, when we are now dealing with numeric variable, or we call them quantitative. You know, I told you that nominal and ordinal, we also call them qualitative data. They are qualitative. Yes, but interval and ratio, they are also called quantitative data, or you can also call them numeric data. Are the same, quantitative, or you are classify them as numeric. Now, you see under ordinal, under quantitative data, they are as well grouped into two. Some are discrete, some are continuous. Now, what do we mean by discrete? Discrete, when we are talking about discrete is a nominal data that has finite number. You understand? It has a finite number. That's finite, which means, for example, now, when I'm talking about year, for example, year has a finite number. Are you with me? So it's discrete. Now, temperature is continuous. Year is an interval data and as well is a discrete data. Why temperature is interval as well, it is continuous. Now, most of the time, the difference, how do we know the difference between a discrete variable and a continuous variable? We can know them. A discrete variable cannot be subdivided, but a continuous variable can be subdivided. Let's say, for example, now we have, look at weight. You know, when you're dealing with weight, you have so points, maybe 50 points, so kg. Are you getting me?
Yes, sir. Yeah,
For example, we have something like 50 points, so kg. So it can be subdivided. It can be subdivided. But discrete cannot, you cannot divide discrete data. You cannot further divide discrete data. They are what? They are known. They are known. Now, before I move on, I would love to ask zip code. Is it categorical or numeric? Zip code, just type it. Is it categorical or numeric? Zip code, is it categorical or numeric? Okay, categorical. Is zip code categorical or it is numeric? Okay, so I would also agree with you that zip code is categorical. It is not numeric. It is not numeric. Most of the time, for numeric data, you can perform operations like addition, subtraction, multiplication, division. And when you perform such operations and them, they make sense. Now, if you have zip code of Nigeria and you have zip code of Canada, if you add them together, you can't gain any insight from it. So this is the zip code of Nigeria and this is zip code. And so okay, zip code of Nigeria plus zip code of Canada. What will it give me? No. So we cannot classify as a numeric data. So we classify such as a categorical data. So those are the things I want us to note at first before we now move on to data visualization. Now, under data visualization, we will take it one after the other. We have when dealing with univariate data, when dealing with bivariate data, and when dealing with multivariate data. When we are talking about univariate data are those type of data that consist of just one values. We are dealing with just one observations, which means when dealing with our column in our what's it called in our data frame or in our data set, want to look at the behavior of just one column. Such data is univariate. Now, if we now have two data that we want to observe, if we want to look for relationship or anything, it is no more univariate. We can call that what? Bivariate. Now, if it is now more than two, then we call it what? We call it multivariate. Now, when we have univariate data that is categorical, when you have a categorical variable, how do we deal with it? Which approach? How do we visualize univariate data that is categorical? Let's say, for example, now collect sample for a questionnaire, and in the questionnaire they are to fill in their gender, male, female. You have about 500 observations. Now you just be having male, female all through. Now you need to analyze, you need to check, you need to visualize those gender. In such case, what is the best approach? Which type of visualization can you use for such? Now, when you are dealing with univariate data, before we even start that, let me import the data we'll be using today. So, import pandas, speedy, import numpy as np, import matplotlib .pyplot as plt, import seaborn as sns, import matplotlib as npl style use ggplot. Okay, let's say our df equals to, I have a data and the name of the data is pokemon.csv. So let's visualize the data. Let's print the head of the data. Let's see what we have. So it's loading. I don't know. kind of loading. So let's see this